it felt like sand.
I wrote it yesterday morning before coming to class, and it was legitimately like 35. Yeah, like before class.
Okay. We're up and running, whatever you want. Okay.
Okay, we can get started. This is Weather Watch for February 7th. I'll let a week-long infrared loop of clouds and occasionally the surface. Several interesting things I want to point out. So first, starting in this loop here, you can see it's been perpetually raining and snowing over the western portion of the United States for a while. Previous to this, they've had moisture. You can see a nice train of moisture coming straight from the Pacific Ocean, eventually making its way on shore. You can see that reflected in the high clouds, and that eventually moves over our region. That's a portion of the freezing rain we got a couple of days ago. But we'll watch this again here. You can see it's stemming all the way down from the latitude of Hawaii, which is off this map here, and it stems all the way up, being pulled in mountains. Ton of snow in the mountains, a lot of rain over this region, 10 to 15 inches of precipitation along the coast of California. That's really good for going into the summer when that all melts. So that's the first thing I want to point out. It's been really wet and rainy in the western portion of the United States, brought us some of the moisture for the freezing rain, which I'll point out here as I talk about here. So we'll watch this plume of moisture. You can see eventually all of it makes its way into the western portion of the United States. Now it's coming over, now it's in the Central Plains, and here it begins to form our freezing rain. And then it was slippery Thursday. Luckily we had sun, so that didn't last too long. One other thing I want to point out, there was a cold front that moved through the central portion of the United States, and so you can see that. It was as intense, so you can see it from space here. So I'll let it play again because you can't really make it out too often, or too easily, so we'll have to pause this once this restarts. But that was in the central portion of the United States. Places in Texas and Oklahoma got up to 90 degrees Fahrenheit. And so if we could go to February, yeah, that'd be great. February 3rd is when it was moving through. And if we go to 1730 UTC here. And you'll see in the break of the high clouds right here, stretching through Iowa and going into Nebraska, this is the cold front moving through. So you can see it's warm. The satellite is seeing that the surface is warmer ahead of the front and colder behind. That's that front moving through. If you just drag it a little forward, we can watch it. So you can see it progress southward through the just central portion of the United States. Like I said, 90 degrees in Texas and Oklahoma, and we'll watch the passage of that as it moves through. But if we go back to 1730, I'll just point it out again here. You can see it from space, which is kind of remarkable. There it is. There's a cold front moving through. And it was like a bow that just moved straight southward along the Rocky Mountains over the Central Plains. Unfortunately, didn't bring any precipitation to that portion. For us, we could have gotten snow, but we didn't. We had our freezing rain later on. So that's something we'll look at later, is this cold front passage. And then if we let it play again, we'll see throughout this loop, all of the blues, the greens, the yellows, they're trapped into Canada. They're not moving, not the cloud evolution, but the surface cold temperatures. That's where the snowfall and snow cover is. There's largely nothing in much of the eastern portion of the United States, so there's not really cold temperatures overnight. You can see the Northeast had some snow cover, so it got cold. That goes away, we warmed up. All the snow cover is largely to the north, and it just has remained there. We haven't gotten as cold as we had been because we just don't have the snow cover, and that seems to be a theme for all these other portions, where it's all just staying in Canada for right now. And you can see that throughout this loop. All of these yellows, greens, blues, that comes down and goes up with the day, that all just stays in Canada. Another thing I want to point out, it's been largely unorganized. As you can see throughout this whole loop, as we watch it forward, it's hard to make out any nice swirl over us, any nice cyclone, anything. Maybe there's one in Canada right there that moves to the east. That's about it. It's been largely just, zonal flow. Not really anything organized over the CONUS, at least. Which means we haven't had any real precipitation over us for anything here.
So Ed Hopkins emailed me this morning, that he updated the grass, but also he mentioned that as of yesterday, 11.5 inches of snow have fallen this season, which puts Madison in second place for least snow. The least for a total season was 4 inches in 1901 and 1902. And the old second place was 1967-68 with 12.7.
Okay. So we need 1.6 inches and we'll be the third least snowiest ever. I don't even know if that's something to celebrate at this point. We haven't even had a foot of snow and it's February.
Right. One thing you mentioned,
Yeah.
Patrick, I think is really interesting is the fact that, and we'll see this in the current forecast, is that a lot of these weather systems have been very moisture, water vapor starved.
Yes.
Right, and maybe it's because we haven't had a really vigorous cyclone at the right latitude to transport a lot of water vapor up to our
Yeah.
latitude.
Yeah, I would completely agree. It seems at this point, a lot of the moisture is coming from the Pacific, so it moves over, it rains out, and then we just get the remnants. At least our portion, upper Midwest. You can see that's really where the moisture is coming from. There's not really any good push of moisture from the Gulf at this point.
Or just the air over the Gulf and the southeast is so
Anything,
dry,
yeah.
you have to lift it north of us before you get much peace.
Good point,
I'd
yeah.
be willing to bet that a geopotential height anomaly time series at 35 degrees north and further south would have almost nothing for the last several weeks.
Yeah.
Because it's exactly in line with what you're saying. We haven't had any excursions of, trophiness to the south, which would then on the return side bring the water vapor forward. It just hasn't happened.
Exactly. Yeah, and we'll see that, some of that reflected in the current upper level charts where it's hard. There's just zonal flow from, southern Canada all the way down to the Gulf, so there, you can't really get any system to generate anywhere over us, at least. At the end of this loop, I'll point out.
I was gonna say, but the odd thing about that though, is that even with that zonal flow, we're still getting, well, I guess it's not that odd. We're cold some days, we're relatively warm, and
Yes.
so the temperature variations have been pretty tight.
I was going
That's
to
right.
agree with you,
Yeah.
Michael, that I think that it's unusual. I mentioned it to my class today. When you look at the satellite movie, it's zonal flow at our latitude, and you think that almost always guarantees above normal temperatures for us. We haven't been deeply below normal, but we haven't really been above normal.
That's true.
So they've somehow survived the onslaught of the subsidence. Maybe it's just because the warm bubbles are so small, they get stretched out, that they don't have any staying power.
So it's too rapid.
Yeah,
zonal
something
flow,
like
it
that.
just takes that
And
one
too
over.
deformative, perhaps, the combination is
Yeah.
enough.
From a sort of longer time scale perspective, the large scale waves, the long waves have been really low amplitude for the last few weeks.
That makes
And
sense.
the synoptic scale waves haven't really changed in their amplitude, so it's really been, I think that's exactly what's going on, is that we have these little, little excursions, but we don't have the big ones from the
Yeah.
large scale flow.
Very interesting.
Right. I completely agree. Yeah. The only thing of interest in my eye is at the very end of this, we'll see a nice development, which is reflected in the upper level charts. It happens over, the system moves just zonally over Canada, and then it sort of explodes or becomes more pronounced, I should say. It's this system here. And you'll see it gets deeper and deeper, and you can make out the cyclonic swirl. But even this is pretty unorganized compared to what we have had. So, because we go to now, so that's all I want to point out here. Can we go to the Oklahoma mesonet? So I pointed out that cold front. We can take a look at the mesonet station. There's one mesonet station specifically that captured a really rapid temp change. All of them did, but it's this one right here, which is, I think we just have to click it again. This one. Goodwell, Oklahoma. If you've ever been there, congratulations. I have not. Let's go to the full meteogram here and change it to 5 days. So we'll go backwards here. So here we can see the red line is temperature, the green line is dew point, or contour I should say. Pick out the front.
Yeah.
So here we have, if we could mouse over this just general area here, temperature is 87.6 is what I saw for the high. So that's 88 degrees, okay? Now let's just hover around, 12 hours later. 16 degrees. So 88 to 16 degrees, that's 72 degrees temperature drop. 12 hours, same time, you can see the winds went from northerly to, went from westerly to northerly. The wind speed, the blue contours increased rapidly, so this was a pretty pronounced rapid temperature fall. There's a cold front. You can see it was cold for one day. They got up to 40 degrees. And then they're back to 80 degrees the next day. So, maybe that's a sign of what we were just saying, where these waves have been short-lived, if anything. There's just been rapid recovery, and they haven't really stayed around for a while. As you can see, it was really warm, got cold for one day, and then is back to warm the next day. Some of these locations, 87, 88 degrees in February is not common in Oklahoma and Texas, so they've had record highs for this, but 88 degrees to 16 the next day would just be weird, I think. Especially if you were, I've said this before, if you were an animal, you had no idea what was going on. It's summer and then it's winter the next morning. I just think that'd be really weird.
And
experience.
Can we just do this? We go from the peak to the point where the inflection point is on the drop?
Oh, yeah.
Because you're right, 70 degrees in 12 hours is already enough, or 24 hours, but how about from there, 86-ish, 87, to about a little bit further down, Patrick? Right there. Yeah, 47. So that's 40 degrees in how much time?
3 hours.
3 hours.
Yeah, 40 degrees.
That's a movie.
So, right. And imagine you go out for a drive, it's really nice, you're gonna go out to the park, it's 88 degrees in February, and then you don't have a coat because it's 88 degrees and all of a sudden it's 47. By the time, you go out for your walk and you come back and you're freezing cold.
Yeah.
Because that's freezing cold for Oklahoma, 47 degrees.
Yeah.
Yeah. So, and all of the stations picked this up, especially over the Panhandle, as you can see. Okay, so that's the cold front. Could we go to our super peaks, please? So we'll take a look at what's currently going on in the upper levels first. And so we'll start at the jet level. Let's go 250 here. And so from this plot, we can see this is wind speed, and then station plots at 250 degrees, so 250 millibars, about the jet level. And what you can make out is we have just a large zonal jet. The true cold is north of this jet, so in Canada, that's exactly where we saw the cold air in the infrared. And then it's just largely homogeneous throughout much of the eastern portion of the United States. We haven't really had the really cold air, we haven't really had the really warm air, we're just in this middle ground, and you can make that out here.
Yeah, so I'm just trying to think, Andrea's point about the lack of really long waves with significant amplitude. I'm wondering also, is part of the fact that and then John's question about, the notion that with westerly flow you'd expect us to warm up.
Yeah.
I wonder if all the warm air is just above a persistent inversion over the central and eastern United States. So that, because if you remember on, was it Friday to Saturday, or Saturday to Sunday, we went from relatively warm to really chilly. Maybe it was on Monday that was really the chilliest day, right? So Sunday was fairly decent.
Yeah.
But the depth of that cold air on a Monday morning couldn't have been super deep.
Right.
So I wonder if we've had this sort of inversion, so all the warm air just above the surface hasn't been able to really mix down.
Yeah, that would make total sense. I know in the map list in Colorado, places at elevation, not too high elevation like the NCAR Mesa Lab, was 60 degrees for about 24 hours as this cold front moved through. So it was completely shallow, completely below them. Places like Denver got down into the teens. So you just drive up to, where you can see the lab, and you go from 16 to 60 degrees. So that would make perfect sense. That's an extreme example. We can't really measure that here, but that would make sense. This is just, it's really cold right near the surface, but above it, it's pretty warm still.
It'd be worse with a broad snow cover in the central U.S. I mean, imagine that. You could bounce a basketball in that inversion probably.
Exactly. And we'd probably be much colder, I would assume. Maybe this pattern might also have shifted if it's been persistent snow cover, but we don't know because we haven't had that, unfortunately. And what you can see, that cyclone that I pointed out at the end, is right where you'd expect it. There's a really elongated speed. I wouldn't necessarily call this a jet, maybe it's just a jet streak, but right in the exit region where you'd expect it, that's where it was sitting. So you could expect that to develop further because it's perfectly aligned with the jet streak at 250. If we could go to 500 at the same time,
Yeah, that would be a great case for next year.
much of the same thing. So this is going lower in the atmosphere. We have completely zonal flow from the US-Canada border all the way to Texas. So it's pretty hard to get something to develop when you just have this persistent westerly flow. You can see one wave making its way onshore. We saw a little moisture beginning to move in over the western portion of the United States. And then there's a trough right where you'd expect that cyclone to be located, right downstream of the trough axis. So that's going to develop. This thing might produce some weather for the western portion of the United States. Other than that, you look at this, probably not much
Yeah.
going on.
Even the one on the west coast probably meets the confluence meat grinder over western Montana.
Right,
It gets
exactly.
just stretched right out.
Exactly. Yeah, not anything spectacular. So, should expect it to be pretty boring based on these two maps. But if we go to 850, we can see that frontal passage we had yesterday is well represented at 850. So if you look at the temperatures here, you can see here's a thermal trough, and we have a northerly component to the wind, so there's pretty good cold air advection going on. This was that cold front that moved through yesterday. Although temperatures didn't drop significantly with the front, we got pretty strong winds. You can see that at 850, where you have, here's a little trough, little cold air, and then right on its heels, it's warm again with southerly winds. And so, again, another short-lived cold intrusion, you could even call it that, where it's still pretty normal for this time of year, but shot of cold air, and then it's right back to warming right on its heels here.
Right. Another really neat thing on this, and I haven't looked at the radar unfortunately this morning, but I would guess that we might see a band of precipitation across the northern Mississippi, Alabama, and Georgia. There's fairly significant frontogenesis going on there, and the dew point depressions are
Yeah.
pretty small, at least on the warm side of that boundary.
Yeah, that's exactly right. There was, I know yesterday, there was actually some severe weather, I think a couple tornadoes from just this frontal passage. So I would expect it to still be ongoing. We could take a look at that for sure. And it is moist, as you point out.
The
But
maritime cyclone's something else too. Look at the thermal structure in that.
oh yeah, look at this. Yeah, very nice thermal ridge.
Development.
You can see really strong northerly flow or
So,
southerly flow. So you could expect this thing is probably producing pretty significant weather up there, but unfortunately not for us, which is kind of sad. Something going on in Alaska, I haven't pointed this out, but that's pretty significant storm. I haven't looked at that at all. But if we could go to the radar now, and that might be the last thing I show here. So we'll see a lot of what we expected. I guess there's not really anything, just small showers. Pretty boring, as we might expect. Some lake effect snow over New York, and then that trough producing some precipitation, but nothing substantial.
too early in the day.
I'm not sure if this is actually making it to the ground either. Because dew point depressions have a pretty high, especially near low levels, so
Maybe look at some surface.
yeah, for sure.
Please.
So boring, according to the radar. And then we'll take a look at the surface plots. Yeah.
15-degree dew point.
23/7, 24/4, so that stuff is not making it to the ground anytime soon. We're very dry. And you can see, here's that, where we saw the 850 thermal trough, really cold air. You can see that reflected where it's colder and cloudy versus where it's warmer and sunny pretty well. But largely, you show me this map, and February 7th, it doesn't necessarily reflect that because we have temperatures in the 60s and 70s, even the 40s and 50s all the way in the Central Plains. Doesn't really look like early February that much. So is there anything anybody wants to see that I haven't pointed
Could we do a sounding
Yeah.
somewhere in the southeast, maybe New Jackson, Mississippi, or it's really, it was interesting in that surface map, you can see that it was, we saw dew point depression about 1 degree Celsius at 850, I think it was, but near the surface, the dew point depressions were several degrees Celsius larger, so pretty dry.
Yeah,
Yeah.
fairly
Increasingly
dry.
drier,
fairly-
starting to go up.
Yeah, and maybe it was a little further north, it may have been a little bit more moist, but that's,
Yeah.
yeah, that's just weird.
Yeah, how about Little Rock, Pete? Can we look at Little Rock? Kind of in the same category, it looked like anyway. Oh, it's a little different.
Yeah, that's more like what we were seeing.
Mid-level moisture max.
Right.
Yeah.
And then look at the stratification there. So that's a
Yeah.
really shallow, relatively shallow layer of cold air that's made it all the way down to that latitude.
Yeah.
Like 850 Cape
Curious.
is pretty decent, I would guess. If you lifted
Oh,
that
yeah.
850 possible, you'd get almost up to 300 millibars maybe
Right.
for free.
But it's kind of, it was just behind the front, seemed
Yeah.
like,
Yeah.
at 850, so,
And look at
Yeah.
the change in wind in the boundary layer,
Yeah.
ranges from easterlies to
pretty
westerlies.
strong too. On there, so.
So dramatic you can't even tell what direction it's turning, in my opinion.
Mhm.
I find
Yeah,
that
true.
hard. It looks like it could be veering, which makes sense, I guess, it's warm advection, but
Right.
not always easy
Yeah.
to tell.
Summer flow.
Okay.
Yeah,
From
yeah. that's-
900.
I know,
Mhm.
all the way to the 100 millibars.
Yeah.
Yeah.
Yeah, so maybe you're right, Michael, that there's a
Exactly.
disjuncture in space between where the atmosphere is ready to go off, which, in the way you expected it, but the forcing is too far south perhaps.
Right.
Could
So
be.
the ascent is not near Little Rock, it's, down over, northern Louisiana or something.
Right.
And we just got that speckled, showery stuff.
Yeah, yeah.
Yeah, that makes total sense. Anything else anybody wants to see? Yeah?
Sorry, I missed the first couple of minutes, but have you looked at the drought monitor at all?
No, we can pull that up quickly.
What?
The drought monitor. Because we're not technically in a drought. We are in abnormally dry conditions that you'd expect. We haven't seen precipitation in like 2 months. At least anything substantial here, so if you go to Wisconsin. This is a change from last week. Last week Dane County was white, which means no drought, but now we're abnormally dry. There's been persistent drought in the southeastern portion of the United States of Wisconsin for a while now. It hasn't really gotten worse or better, but there has been an upward shift in these dry conditions compared to last week and this week now. So that's something to watch too, is as we get potentially missed by snowfall yet tomorrow, will we stay dry? Will this change? Will we keep getting more and more in these drought categories? Something to watch.
There's a lot of grain produced in those places where we have severe or moderate drought.
Right.
Or moderate to abnormally dry.
Yeah.
I wonder what the correlation is between productivity in the subsequent year, if you can somehow level precipitation that comes in with how dry it is right now.
I'm sure you could, yeah.
I wonder what the word is on that.
And it's
Probably
just,
not good to be
it's
this dry.
stayed dry. This is not like a sudden flash drought. It's just been dry for months in some of these portions. Because we just haven't had any moisture and largely a lack of snowfall too.
So it almost certainly means the soil moisture is way lower than it should be.
Yeah.
Because you sublimate that out if there's no snow blocking the way.
That's right. We
So-
can actually look at that. I know
It's
they have
compounded,
this.
I think.
We go to conditions and outlooks, current conditions, and then, well, I think this one is normally updated. If we click this, to just take it off. Oh, they haven't updated this one. Maybe this tab, click this one up, please. Here we go, yeah. Calculated soil moisture anomalies, you can see it's dry
Oh, yeah, okay.
essentially everywhere but where that precipitation
Yeah.
happened over California. So something to watch. Most of the United States has been in these drier conditions for a while. Even portions that got hit by Hurricane Helene and had anomalies and precipitation well above normal, now they're back to being dry. Hopefully this changes.
This may also partly explain, I don't know, Pete, if you could go to a visible satellite image, this could perhaps explain, again, in addition to the fact that we haven't had much meridional southerly flow over us to transport water vapor from the Gulf or from the southeast and south central part of the United States. it's so dry at the surface, there's very little over there. So I remember this time of year, we begin to see kind of a little bit of that speckled convection. I guess there's some that's popping up there, but
Yeah.
it's not really, do we have a closer end?
Mhm.
You can kind of see the convective clouds beginning to form,
Right.
you know.
You want like 7 tones?
Yeah, Southern Plains would be good, yeah, right, up one, up, yeah.
So it's not just black and white, I don't have a color one, but.
Yeah, color, yeah. So there is, you know,
Yeah,
there's
you can
some
see it.
shallow convection developing in the south central part of the United States.
Right.
But, yeah, like parts of Texas, I mean, it's probably well behind the front, it's just too dry
Yeah,
for much to actually happen.
exactly right. This is just gonna be clouds more than anything.
But my recollection was probably around this time of the year, maybe it's another couple more weeks, when you begin to see that cumuliform cloud, development in parts of Texas, Louisiana, Arkansas,
Yeah.
those places.
Yeah, absolutely. And I know they've even had blowing dust already from just the flow from New Mexico into Texas and on, so, yeah. Okay, I'll turn it over for Parks.
Yeah, thank you, Patrick. But what we'll start with is just kind of look at the hazards further over to the, yeah, there we go. So these are the current hazards across the United States in terms of watches, warnings, advisories that have been listed. We were just talking about how dry it's been in the southeastern part of the United States. You can see here they have these so-called red flag warnings for this windy, dry conditions, the possibility of fires developing over parts of New Mexico and Texas. And you can see this very conspicuous band of winter weather advisories, as well as a winter storm watch to our north over parts of central and eastern Wisconsin for later, not later tonight, but for tomorrow into tomorrow evening. And we're going to focus a little bit on the precipitation expected over us, the snow event that we're anticipating largely to our north during the day tomorrow. It's, again, one of these events that's going to be confounded by the fact that it's so dry near the surface, it's going to be hard to produce much in the way of significant precipitation. You have to only go several counties to our north before you actually see anything of significance. The same weather system is also going to be responsible for a significant winter storm over the the northeastern part of the United States from central New York State through Cape Cod, where they're expecting anywhere upwards to a foot of snow over the next 48 hours or so. So that's going to be a fairly significant event. Okay, so let's first go to the current, the current map as depicted in, there we go. Close that just national for now. Let's click on US, please. On US. So this is the 18Z forecast from the GFS. And we can see, again, a fairly quiet day across much of the United States. We can see from the 500 to 1,000 hectopascal thickness isoplex that, that zonal to near zonal flow over the United States would sort of be expected in the troposphere. And again, relatively quiet. Some light precipitation in the southeastern part of the United States. But again, just a really quiet day as we step forward. Let's go ahead to, say, 18 hours of the forecast, please. This is the 6Z, so that's midnight. We can see that weather systems out to our east, to our west, excuse me, has progressed into the northern plains and the upper Midwest. And light snow is expected to begin to break out well to our north. Broad area of warm advection, so you might be thinking, uh-oh, if it's moist enough and we got precipitation, maybe we might be flirting with some liquid precipitation or freezing precipitation. But for us, again, largely because it's so dry, we'll see in the forecast that we're not going to see much in the way of any significant precipitation, at least until afternoon tomorrow. But again, the heaviest snow is confined to our north. We'll do a cross-section in a moment. We'll go to something. Let's go to 24 hours tomorrow morning. And you can see sort of two areas of precipitation. One well to the north of us still, at least in this forecast. I looked at a range of other model solutions from the German ICON model to the Canadian model to UW-AOS from yesterday evening. And the sort of accumulating precipitation gets just to the northern part of Dane County, but largely many of the model solutions have the precipitation confined largely toward north. But a second band of precipitation close to this developing warm front does begin to encroach our area from the south. And we'll do a cross-section in just a moment. Let's go ahead to 18Z tomorrow, 30 hours in the forecast. So this time tomorrow. And largely this precipitation has moved to the east, sort of ice storm conditions, perhaps in western Maryland, and just icy conditions in the Maryland and Delaware area. But this is, again, precipitation has not yet arrived in our area. So what I would like to do first is we'll go to tropical tidbits and just do a cross-section from sort of north central Wisconsin down to central Illinois, please, Pete. At that time, so 30 hours in the forecast. A little bit further down, a little bit further north, central Illinois right there, okay. And we'll go to 30 hours of the forecast. Oh, I don't think it's up. So control quick, and then I think you can release. Get that right, let's see. And we'll submit that, just to what's currently there. Okay, so here's our cross-section. Again, fairly feeble, at least in terms of frontogenesis in this diagram. This precipitation here, I mean, it's not particularly heavy, but it's at this particular time, not much in the way of precipitation. And frontogenesis is weak. Frontogenesis is shown in these pink contours. Just for reference here, again, we're looking at a cross-section from north central Wisconsin down to southeastern Illinois, from A to B here, and we see the isotropes here, not the isotropes, the moist isotropes, theta E contours that are located here in the green. And then the shading is our vertical motion omega with the blue colors indicating ascent. So significant ascent in the northern half of this diagram where we're seeing the precipitation. Theta E, I guess if it's precipitated, we're probably close to saturation, so we have a layer that's, in terms of its stability, is at best neutral. And so with the lifting there, that might be helping to enhance some of the precipitation. And then the southern part of this diagram, again, this is accumulated precipitation, so it's not instantaneous. But some of this might be due to some local weak frontogenesis. But I would like to go to another part of this. Let's go to relative humidity in the cross-section in omega. And you have to do
Submit
that was a
bottom
middle.
Bottom center.
Yeah.
Yeah, there you go. Okay. And so, again, it's a fairly moist layer from all the way from Illinois into north central Wisconsin, but it remains relatively dry over us. We're in this cross-section, we're just a little bit north of the midpoint of this cross-section. So this dry air persists. So even if we have light precipitation occurring over us, we still have to go through this dry layer before we're going to get saturated and bring those ice crystals down to the ground. So this dry air is really hurting us. And this is a very thin layer of water vapor to begin with, so we might not expect much of the precipitation. Fairly deep over the southern part of the cross-section, and obviously much more water vapor to the north. And a lot of this might have been advected or transported northward. We don't have a really deep wave at all, but along these isotropes, the air flowing northward along the isotropes, and it just has to rise before it can actually get deep enough for any precipitation. This might be remnants of the Pacific moisture that came with the system as it passed across the air partial trajectories to verify. Let's go ahead just at one time step, 3 hours. Dan, you can do it, Dan. Oops.
Oh, just do the same.
Cross-section, yeah, we can do it in the cross-section, that's all right.
We've only got to be 6 hours.
Oh, 6 hours, okay. So 36 hours, we can do another, roughly the same cross-section. Precip has just gotten into Dane County. And we'll look at the relative humidity. Again, it's very feeble, forcing, at least in terms of frontogenesis. There are other mechanisms that can contribute to ascent. But now, it's just extremely dry above us. We don't really have a very deep layer of water vapor, and we don't have much in the way of, at least the frontogenital forcing. There's no obvious wave. You might infer maybe a weak short wave just upstream of us, but that's not going to, the curvature of that doesn't seem sufficient to produce much for this. So this disturbance is gonna head out to the east, and we're not gonna see much in the way of precipitation. Let's go back to the pivotal, please. And we can step forward in this every 3 hours, and you can see the approach to that precip. And we can keep going forward a bit, and it's over by, by 0G tomorrow evening. We'll probably see decreasing cloudiness as the substance begins to take over us. See a nice maximum in cold advection just over us into our south. We expect subsidence and things to begin to clear out. It'll probably get quite chilly on Saturday evening. Then the focus turns to this whole disturbance moving toward the East Coast. By this time, by tomorrow evening, we have a cyclone in just northwestern West Virginia. A lot of freezing rain out ahead of it, and then ice pellets, and then just moderate snowfall accumulations in southern, just beginning to approach southern New England. So Pennsylvania is getting hit pretty hard at this point. You can see again, there's a fairly stubby but evident warm front that extends from this cyclone out to the east. We can go to 850 hectopascals of temperature. Maybe it'll show up a little bit better there. Let's see. More significant. You can see the warm advection. Warm advection clearly here, and it's sort of it's maximized over parts of eastern and northeastern Pennsylvania. We might expect to see a nice bullseye in vertical motion. But we also see we have some nice confluence across this baroclinic zone. So that's going to tend to bring these isotropes closer and closer together. So the possibility of a band of sort of heavier snow beginning to develop is evident there. Getting back to us, again, you can see really strong cold advection located right over us, and that's going to help foster some subsidence and the clearing that we talked about just earlier. Let's go one more time step. Let's go back to the surface map, please. And just see why New England's going to get hit pretty hard with snowfall. So this is, again, 6 p.m. Here's that band of heavier snow beginning to be realized here. Things clearing out in the Maryland, Delaware, Virginia area. And one more step forward, as it's arriving in the Boston area. Again, fairly significant snowfall. Not a very deep low. This is one of the rare occurrences, I guess, where they might get significant snowfall without a nice big broad anticyclone to the north to keep it frozen. There's often the question of, is it going to turn to rain around 495 or west of 495, stay in snow, but that's not going to happen. If you're from New England, from the Boston area, you know the story. But at least in this forecast, it looks like it stays cold enough for them to be all snow. Let's do a cross section.
The zonal that thickness gradient is from the Rockies all
Oh yeah,
I know,
so
it's amazing.
crazy.
That's just incredible.
So there's gonna be snow and freezing rain in Philadelphia on Super Bowl Sunday, so maybe, depending on the outcome of the game, they can push the cars before they torch them. After the game.
Well, I think by Sunday Sunday afternoon should be pretty nice, because as we all know, it's always sunny in Philadelphia. Right? Okay. Anyway, let's go back to. We'll stay at this time. Let's do a cross section through this band at 6C. Well, at least one click ahead, I guess. And we'll do it. We can almost do north-south. Like that. It doesn't have to go that far north. So it'll work.
Right to my hometown, right in the middle of my hometown.
And we'll submit that.
Yeah.
Look at that, frontogenesis.
Very nice.
Look at the vertical motion at the head of this front. Again, the southern part is out over the water, and we have the sloping area of frontogenesis, and associated with it, the broad area of ascent. Yeah, so this is sort of a classic setup for significant precipitation with if we have water vapor available. If we go back one click, and we'll then go ahead one click, you'll see, from this time, you'll see, oh, we don't have to,
I'm sorry.
yeah, we'll do the cross section again at this time. So we'll see a pretty robust signal.
Yeah.
Maybe even more so. But notice this, at this point, obviously, the cyclone and the associated ascent is well to the east, but in just 6 hours, you can see how this really changes. So we can, click ahead, You can see that burst of heavy snow around midnight or early in the morning hours in Boston, and then we go ahead one more click, and the thing just sort of collapses as the cyclone heads out and all the forcing for vertical motion heads out. But we still have some lingering ascent. Actually, no, that's descent at this point over this area as this clears out. So burst of snowfall for this area, looks for centered around midnight to 3 a.m. for the Boston area. Pretty decent snowfall. Let's look at the amounts for that, please. We'll go to tropical. Yeah, we'll stick it. We'll do that. Scroll down to the bottom, please, and let's look at just the 10-to-1 ratio, and we'll also zoom in just so you can see that.
We should do the 24-hour total.
Yeah. Okay. So let's do 24-hour total. So this is actually not particularly impressive if it's, if the ratio is 10-to-1 with 4-inch amounts. But we'll look at a couple of different, actually this is only through Sunday at 6-8. We can go ahead to 48 hours at least. This is when the heaviest snowfall is.
Yeah,
Look at
there
that.
you go. That's
There you go. So you're right up in that 7.2, 7.4 inches, around 7 inches or so from far western Massachusetts, Chicopee, all the way up to the Cape. So nice band of really heavy snow, and it's centered along that. The icing conditions they had in the Mid-Atlantic and northern part of the district were not much in the way of snowfall there. It's really concentrated along this as that Genesis band sets up.
It's too bad it's gonna be like midnight to 6 a.m.
Yeah, not much to see, unless you look at the lights outside. It's
Yeah,
pretty
yeah,
small
yeah.
light. Let's also just look over us for the snowfall that we're expecting tomorrow, minimal snowfall we're expecting. Yeah, 0.4, but if we even get that, but again, the heavier amounts to the north. Where they have a winter storm watch, it's interesting to know, and this is 24 hours. Let's go back a little bit earlier, because we know it's gonna be over by tomorrow evening. There's that band with a little bit heavier snow. And in fact, we could probably go back one more click. Yes. So there's the
Fun to get in tomorrow.
And as we always want to do, we don't want to rely on one single deterministic solution. So let's take a quick tour through some of the other models. We'll start with ECWF. This time here it has the band further to the north and maybe a little bit lighter. It'd be also interesting to look at this for the East Coast event. Let's go down to the GDPS. Okay, 1.2. So that's the band is a little bit further to the south. And then finally, the icon.
Pretty robust 0.4.
What's that?
Pretty robust 0.4 inches for us among all these.
And just very quickly, and then we'll look at the rest of the week across the nation. Let's go back to the East Coast and just kind of run through those same suite of models. Northeast.
It looks to me like next Saturday is the big one.
And we'll go to 48 hours, yeah.
Setting itself up,
Okay, so this is the icon has the heavier snow a little bit further to the south here, but again, it's in that band, and I think those are all largely phylogenetic enforced. Go to GDPS, Canadian model. Well, kind of spotty, doesn't really have a really robust, also it looks kind of just very bizarre. Trust me.
Well, there's a lot of ridgy mountains that are north-south.
True.
Yeah.
That looks a little suspicious.
Yeah, but even this,
Yeah,
no mountains over here, unless they're really high waves. And let's go ECWF.
These are the effect of the tariffs.
Yeah. So at least it seems a consensus, a very quick consensus, if you will, of the model solutions for this seems to suggest that the heaviest snow might be just south of the Boston area along the southern New England coast. So something to look out for. But again, they had this broad area of winter storm watches from just west of Albany all the way to the Atlantic. Finally, let's zoom back out and look at the rest of the forecast for the remaining part of the week. We'll kind of just quickly step forward at the surface. And we'll start, I guess let's go to Monday. Monday, that first anticyclone that was just over us is now shifted to the east, southeast of us. We're still in sort of weak cold advection. Let's quickly go
There's
to.
like no precip on that map.
Yeah. Some just south of the
Few hills on
City.
the Wyoming, Montana border with the wind coming up, so we just got snow.
That's it. Yeah, we get, the southerly flow, this anticyclone as it's head to the east, there's sort of a so-called return flow around it. We get either take some, get some precipitation from the Gulf of Mexico, but again, it's way to our south. A lot of dark, a lot of dry air north of that, so as to prevent anything significant from approaching us. We could actually look at, this isn't really fair, but we'll quickly at the surface relative humidity. And you can see, all that water vapor, significant water vapor is confined well to our south at this point. Okay, back to the surface now. And we'll go ahead to Wednesday. So this, again, kind of flips off, heads east. And then we have another area of precipitation well to our south. This, I think, has a better chance at least getting to our latitude, at least in some of the forecasts. If we go ahead just 12 hours, 132. Just misses us, it appears, so we go to 144. This is Thursday evening. We've got another big storm or moderate storm for the East Coast. And we just stay cold and dry. 168 or 192.
That's a little different.
Okay, so how do we get there? 168, so if we're at Weather Watch this time next week, unfortunately I won't be able to be here for that event. We have, again, I haven't looked back at all of this, but cyclone that's emerging from the Rocky Mountains, we step ahead 3 hours just to watch 6. Yeah, that's 69 in the calendar. So that's, now we have some Brunel flow that's developed over the continent, another 6 hours at 180, and bang. So, this I don't think is, this precipitation and the water vapor associated with it is probably not having its origins largely from the Pacific, but I think from the Gulf of Mexico, as it's now opened up. If we even look at the relative humidity at the surface, the near surface relative humidity, we've certainly loosened up a lot. This is coming out of the Gulf. It's, and this is where, I guess, where some of the precipitation is already starting to fall. Okay, back to surface map. So this is at least a decent shot at some snowfall. 186, but again, maybe concentrated toward north. This looks kind of bizarre. Yeah, the speckled precipitation. And if we go to 182, 192, I can't see the numbers. So we have a shot at something a bit more, a more potent weather system by the time we get to the end of the week next week. If you look at total, but what's going on? Heaviest, we're down here.
I don't think we're done yet either.
Yeah.
It's a 24-hour, 10-1.
Yeah, go down a little bit. Sort of 3 or 4 inches. And if we were just,
What about
well, that's
6
the only,
hours?
that's really the only event. So if we do total, we can just subtract a 0.4
Yeah,
off of this.
right. But it does encroach, the higher amounts encroach as you creep forward because it's not over.
Yeah, look at that. Yeah, there we go.
Yeah, 6. I'll take 6.
Let's go a little bit further. Let's go to 240 hours. Let's just look at it.
6.
All right. So something perhaps more exciting to talk about next week at Weather Watch. But again, sort of very quick synopsis for this weekend. Tomorrow, cloudy with maybe a few flakes of some light snow. Again, heaviest well to our north. We may, scrape by with a dusting to maybe half an inch or so at best. And then we, tomorrow night clearing out, getting significantly colder, and then a cold day on Monday. And then small opportunities for very light precipitation throughout the week until we get to, I guess, Friday night into Saturday next weekend, where you could see a significant snowfall. Anyway, thanks, Patrick, for leading the earlier
Can I
part of
show
the
something
discussion.
real quick?
Yeah.
I don't know if it'll still show on the new run, but I saw something interesting on the Northern Hemisphere GFS.
All right.
This one.
While we're going, we slipped the spot in the all-time rankings this week. We're 5th warmest right now.
Yes, I was gonna, there was time.
So what I was looking at was this ridge over the Pacific that blasts up and changes to you end up with an anticyclone over the North Pole. Like right over. I didn't know if that was like a sudden stratospheric warming.
No, so
signal.
this is like the setup. We're about to go through a huge pattern shift. There's been pretty low amplitude, like planetary scale wave 1 and wave 2. And basically what that means is like, are the ridges in the Atlantic and the Pacific getting high enough into the Arctic to make a wave 2 structure? And this is pretty much the first time this season that they've been able to do that. And when this happens at the tropopause, it causes, or it can be associated with an upward wave activity flux where you start to get this wave 2 pattern in the stratosphere, and that can lead to a sudden stratospheric warming.
What are the implications down
Yeah,
in the
so-
troposphere after that?
Well, right, as I haven't looked today, but the models, only a few of the ensembles were hinting. We've had such a strong zonal flow in the stratosphere for so long that it's gonna take a couple of punches like this to really weaken the vortex. But once it is weakened and once it does have that wavy structure, it kind of adds a persistence to the tropospheric flow to be a little bit more high amplitude. But I think we're shifting in that direction where in the next week or so, we'll see a pattern shift where we will have this long wave background pattern that can hopefully give some more of the synoptic waves a little more
This is 5 hectopascals, so way up there.
yeah.
Well, I bet that probably ruins our chance for being the warmest winter, either at 850, because if it gets to be higher amplitude, we'll have a few more excursions of cold air.
But also a few more excursions
Of warm air, I guess, yeah, that's right.
Yeah.
I presume it's been as cold as usual at high latitude, I don't know that, and it just hasn't been able to get out, but maybe that isn't true.
Yeah.
Yeah, so, I don't know, maybe it just puts us back in the running, I guess, possibly.
Do you do this for the CFS?
Mhm.
Okay.
I'm not sure I get the CFS data. I'm not taking a look.
But even, yeah, Eastern Canada.
Yeah, I know.
Yeah,
No, it's
thanks
nice.
Pete for driving, thanks Patrick, and thank you all.
Yeah, thank you guys.
No, Michael, next week, he's got a meeting, so.
What's that?
I said, no, you next week, because you've got a